So thank you very much to Tariq for the presentation, and we have plenty of time for discussions if anybody has any questions to begin with. Felix.
I have a question because I'm totally newbie in this philological field. Are there any other text alignment tools, and what's the difference to your tools? So do they use the same algorithms or different? Or so what's
the idea, every tools available online has some advantages, Nachteile und Vorteile. So we created this tool to use it because we can control the input text. We can on the export the output format. Some tools are available. You can just copy and paste your text. They don't deal with the big data. So most of them use the same algorithms, but as I mentioned, we made a modification to the algorithm by reducing the search space. Some of them take a lot of time to produce the alignment because if the texts are big, but our tool is available for free first, and as I said, we can change the input and the output as we want to. Other tools are restricted to.
Okay, can you say something about the syntax-based part?
Yeah, as I said, syntax-based part. We are interested only on the order of the words and the order of the characters in the word. We don't, for example, look to the part of speech if this word is verb or noun or something else. We just look to the characters and we compare the two words according to their syntax, to their characters.
So there is no real syntax-based thing in there?
In computer science, syntax is the order of the characters. I don't know if you have.
You're talking about single words.
Yeah. So we mean by syntax-based that if we have two words, we don't, for example, lemmatize these two words and compare the lemma, or we don't take the part of speech of these words. We just look to the order of the characters in these two words. So in this case, we called them syntax-based. Actually, we had a big discussion about this word syntax-based, and the new version of the work. We deleted this word because most of people had problem with this syntax-based. But from my point of view as a computer scientist, syntax in programming field is the order of the characters.
If I understand it right, you need to know in advance that the text that you will compare are actually already
related.
That they are very similar. So you can't just find similarities from scratch from somewhere. So
yeah, I mean, no, we need to know this information if we want to use the modification, to use this reduction of the search space. Otherwise, you can use the general algorithm without any information about the relatedness between the two texts. So if you have arbitrary two texts, you just copy and paste them and use the general algorithm. In this case.
And how does your algorithm compare with in the quality of the result, for example, with a simple diff algorithm that whatever for changes in a program or so that you just whatever on GitHub you see the difference between two file versions via a diff algorithm?
Yeah, the idea right now we have as I said, we just started three months ago, so we are in the first steps. The idea, all or most of alignment algorithms or pairwise alignment algorithms use the same algorithm, which is Needleman-Wunsch algorithm, but each tool makes some modification to this algorithm to produce more accurate results. So we took the general algorithm, as I said, on the what we have added is the refinement criteria, like the case sensitivity and removing non-alphabetical characters, and the reduction of the search space. So that right now we have evaluated this tool on the Greek text and the Latin text. It works for pairwise alignment. We can see 100% correctly, but for multiple alignment, as I said, we still working to improve the algorithm.
I have a question too, and a little bit in the line of what Wolfgang said before. You mentioned in the abstract and maybe in the presentation as well another possible use case in the detection of text reuse and so similarity between texts that are not immediately aligned, like multiple versions of the same text or multiple translation or multiple editions of the same text. I know that many people in the Leipzig group are interested in this text reuse and dynamics. And have you tested your tool for this kind of? That would maybe a question for Chiara.
We have not.
Okay, not yet. Other questions?
You were showing this matrix where you were showing this optimal path, and I can't say that I really understood it, but so one simple question would be, so you come into an optimum there at 18 and then you're drizzling out going back to 10, so why don't you go to an ending that is at 16 or at 12 or something?
Here, because when we want to calculate the optimal solution, we always start with this cell and to see that this value came from this cell, and the value of this cell came from here, and the value of this came from 18, and
so the point is you have to end up in the lower.
Yeah, exactly. Until you reach to the.
Another question from me, if you done with answering this last question. You mentioned also multiple possibilities in visualization. Are you also interested in allowing many other?
Yeah, we are collaborating with Dr. Stefan Yankee. We will use his tool, this Travis tool, to use it on our tool and also on our tool, to integrate it with our tool.
So the kind of visualizations that you show, the graphs and the paths. I understand. Any other question from the audience? Well, if there is no other question, we can conclude the formal session of the seminar. Oh, sorry, Rainer. Of course, Professor Furch.
So using this algorithm from bioinformatics, if the algorithm, the original one, bioinformatics, also follow, let's say, letters?
Okay.
Or did he follow
nucleotides?
Things?
Sorry, I didn't.
What he used, as you said before, in bioinformatics for measuring, let's say, nucleotide elements. You know, how are they coded, or how are those elements being described for the algorithm to snap on them?
Yeah.
Are they expressed? These nucleotide elements also expressed in letters?
Or
are they expressed differently?
The nucleotides are expressed in letters. For example, we have T, C, K, guanine, adenine, cytosine.
So,
You have letters. Then in this case, it's very simple. Just you compare A with A, G with C. So we extended this algorithm to compare token with token, according to the syntax-based.
So there was no big, let's say, transfer necessary to make
Exactly.
the algorithm working also
Exactly.
in real letters, so to say, in written text. Could you think of abstracting the algorithm from letters or things that have to be expressed in letters to other things, or does the transfer has to happen in expressing, so to say, other things into letters? If we try to think about images, for example, and let the algorithm find similarities, then first you have to translate, so to say, those things that the algorithm should analyze into letter expression, or could you think that the algorithm can also work with, let's say, visual elements per se?
No, I guess it can work for for everything. Just you need to find to know how to compare this thing with this thing. In the general form of the algorithm, it's comparing nucleotides or proteins letter with letter. You can in our case comparing token with token. Maybe you can compare location with the location, or a pixel with pixel. So we can use the same.
Have to be letterized, so to say, before, or can it be expressed differently?
I guess in this case we can align, maybe, I'm not sure, but you can align two images if you take into account the pixels. On each pixel has some attributes like maybe RGB or something. Then you can compare them, or using some score function. Here we have matching, mismatching, insertion, deletion. Maybe you can say that they are close to each other, not 0 or 1. You can give some value to the distance between them. According to that, you can.
No, that's not bad. Another question in connection with this is. Do you have a feeling or, let's say, experience how it behaves, let's say, memory-wise? That means, how does it blow up in memory requests when you say you don't only compare two different, let's say, syntax lines in your definition of syntax, but to, as has been asked before, to compare, let's say, an indefinite number, or let's say 50,000 different syntax lines. What will he do then? How is he implemented? Where is it running? Will he stop working?
No, it's not stop. That depends on the laptop or the machine that you run the algorithm on.
But is there, let's say, an innate sort of memory blocking after, let's say,
till now
the number of 50 elements that he has to
till now we didn't face such problem. I tested this algorithm on about 10,000 tokens. It's 10,000 with 10,000, and it worked, but it took a long time to give the results. About 20 minutes.
And how do you run it?
On Python, I run as a Python script because now the tool is available online as a PHP, coded with PHP, but it's also available as Python. You can download it from GitHub and run it on your machine.
Any other observations or remarks? And if not, we thanks again Tariq, and we move to the informal part of our seminar. Thank you very much for coming, and thank you for this presentation.